Hey guys, here we go with chapter 10. So this is the last chapter that we have to do for AP Calculus. So we are almost there. Hang in with me for one more chapter. This chapter is all about finding areas and volumes using a lot of the calculus concepts that we've learned throughout the year. So up until now, we've practiced finding the area between a curve and the x-axis. So this should look pretty familiar to you because this is what most of the integrals that we have worked with this year have looked like. So we know that if we want to find that area, we're going to do the integral from a to b, because those are our bounds, a to b, of our function, which is f of x, and then we close the integral, we know, with a dx, and that gets us our area. All right, well now we're going to be finding the area between two curves. And we can see, even just by looking at the picture, that this is different. So let's look at how we actually find that area. So if f and g are continuous functions, with f of x being greater than or equal to g of x, so in other words, we're going to call f of x the top function, because it is above the other one. And then g of x is the bottom, because it's below the other one. Then we're looking still from a to b, and then the area between the curves between a and b is the following integral. So we still do the integral, and we do a to b because those are the bounds. But now what we're going to do is we're going to do the top function, which is f of x, minus the bottom function, which is g of x, and then we'll close that whole integral with a dx. So let's talk about why this would actually make sense. So we said that f of x is the top function. So really what we're doing is top minus bottom. But if we think of what the integral from a to b of f of x looks like, I'm going to just do a quick sketch here. We know that that's this function here, and it's this whole area between the function and the x-axis. Well, then we're going to subtract the bottom function, which is g of x. So if we look at what that looks like, the bottom function is here, and that's this area. And so what we're left with in the end is the area that we're looking for. It's the area between the two curves. So here's the top, here's the bottom, and we're left with the area that's in between. So this top one was our f of x. Sorry, I messed up my colors already. And the bottom function is that g of x. So we're looking at the area that's trapped in between the two functions. So you might be wondering why we haven't introduced you to this earlier, but in fact we actually have. If we look at this integral, which we already know how to find that area, if we think about it, f of x is still our top function. So the top is just f of x. Well, the bottom function in this case is the line y equals 0, because it's the x-axis. And so what we're doing when we find an integral, we do the integral from a to b of the top, which is f of x, minus the bottom, which in this case is 0, and then we close it off with a dx. But we know that if the function itself is 0, then the area trapped there is 0, and so we're left with our integral from a to b of f of x dx. So it doesn't seem like it, but we have really been doing top function minus bottom function this whole time. We just haven't introduced it to you that way. So let's look at what some of these examples look like. Okay, so number 1 says find the area of the region enclosed by the parabola y equals 2 minus x squared and the line y equals negative x. And this is a no calculator question. So the first thing that we have to do, regardless of if it's a calculator or no calculator question, is figure out what this graph looks like. So you have to draw yourself an accurate graph. It's not an option, it has to be done correctly. So I'm going to start by drawing a graph. I forgot my straight edge when I started this video, so please bear with me. That was not a straight line at all because I'm trying to make it one. There we go. Okay, so let's see. We know that this first graph is y equals 2 minus x squared. We know that that's a downwards facing parabola and that we have to start with our vertex at the point 0, 2. So I'm going to make some tick marks first. Alright, so let's see, I'm going to start at 0, 2, and then using what I know about parabolas, I know that I'm going to have points here, right, over 1, down 1, and then over 2 and down 4, so that's going to be here. Over 2 and down 4 is going to be right here. Now if you don't remember what a parabola looks like, or if you forget, or if it's a different function, then whatever, go ahead and just use an XY table and plug in some values. Alright, so I made the parabola orange. Now I'm going to go ahead and I'm going to draw this line, y equals negative x, and I'm going to use a different color. So I know that that has a y-intercept of 0, and it has a slope of negative 1. So I go down 1 and over 1, down 1 and over 1. Did I screw this up already? 1, 2, yep, I screwed it up. This orange point should be here because those are supposed to intersect right there. Hopefully you caught that before me. Sorry about that. I can't count. So not there. I have to go up one more. There we go. And so these intersect right here. So let's see. This is the point negative 1, 1. And this is the point 2, negative 2. So see, very important that you draw the graph correctly because otherwise you end up like me and you screw it up. So sorry about that. But this is the area that we are then looking for. So if we want to find that area, we know it's going to be an integral and we need our bounds. So we know that they intersect at negative 1 and then again at 2. So I'm going to go from negative 1 to positive 2. But what I have to do is I have to figure out which function is on top and which function is on the bottom. So when we look at this graph, we can clearly see that this orange curve, the parabola, is on top the entire time. And then the blue line is on the bottom, which means my top function is the function y equals 2 minus x squared. And then the bottom function is the line y equals negative x. So if I want to do top minus bottom, I know that that's going to be 2 minus x squared minus negative x. And then I'm going to close off my integral and put a dx. So again, top minus bottom. And then we found our points of intersection, and those were our bounds. Well, now we have to actually just compute this integral. Since this is no calculator, the first thing I'm going to actually do is make it a little bit easier here. So this is going to be negative x squared. That becomes a positive x, and then plus 2 dx. So all I did was put it in standard form. And now I'm going to take the antiderivative. So that would be negative 1/3 x cubed plus 1/2 x squared plus 2x plus c, and I'm going to evaluate from negative 1 to 2. So when I do that, let's see, negative , plus, if I plug in 2, I'd get 4/2, which is 2, plus 4 plus c minus, let's see, negative, negative, so that's a positive 1/3 then, minus 1/2 minus 2 plus c. And we know that the c's are going to cancel. Sorry, I'm kind of running out of space there. So I'm going to go up and over to here. So I know that I'm going to have negative 8/3. I'm going to combine that to be a plus 6. And then this is minus 1/3 plus 1/2 plus 2. And if I look, negative 8/3 and then a negative 1/3, that actually becomes a negative 9/3, which is really just negative 3. And then let's see, plus 8, and then, sorry, this should be a plus 1/2, because this should be a minus 1/2. And so we get 5 minus 1/2, which is really 4.5. And so the area trapped between these two curves is 4.5. All right, we're going to do one more, and this is a calculator question. So I'm going to show you a little bit about how to use your calculator to do this type of thing. And I'm going to show you a shortcut. So the first thing I need you guys to do is grab your calculators and make sure you are in radian mode. And we're going to do a sketch of these graphs. So let's see, y equals, let's clear that out, 2 cosine of x, and then x squared minus 1. And what I'm going to do real quick is I'm going to make a note that I put this into y1 and I put this into y2, and that'll be important later, so make sure you specify what you did also, because I'm going to show you guys a shortcut. And then I'm going to do zoom 6 because I want the standard window, so that I can kind of see what's going on here. Alright, if we look, we can see we're going to be focused in on this region here, because we've got our cosine curve going up and down, and we've got our parabola. And so we've got almost like this eye-looking shape right here. So what I'm going to do is just over on the side, I'm going to draw a quick sketch. It's not going to be as accurate as the one that I drew up here, but a good idea of what's going on. So let's see, if I know that I've got my cosine function, it's going kind of like this maybe, and then I know that I have my, that was not centered at all though. Okay, let's actually do a better one, Miss J. Get this out of my way. Okay. That's still very bad, Miss J. But you guys get the idea there. And then we have the parabola that kind of comes down like this. And so what we're looking for is this area that's trapped in between here. Hopefully your quick sketch is a little bit better than mine. Sorry about that. Alright, so what we need is we need to know what these bounds are on our graph. So we need to know what is this point and this point. So we're going to go to our calculator and we're going to find the intersection points. So that one is negative 1.265. And then if I want to find the other point of intersection, I just do the same thing. And I'm going to go over to here. And that is a positive 1.265. Alright, so now I have my bounds, which means if I want to start finding my integral, I know I'm going to go from negative 1.265 to a positive 1.265. But now I need to know what my top function is. So if I go back to my graph here, I can see that the cosine function is the one that's on top. So the cosine, it's 2 cosine x, is on top, and then the x squared minus 1 is the one that's on the bottom. So if I want to do top minus bottom, that's going to end up being 2 cosine x minus x squared minus 1, and I'm going to close it off with a dx. Now, we can put that in our calculator and find the integral, but I'm going to show you guys a little bit of a shortcut when you plug it in. So I'm going to still do math 9, and I'm going to integrate from negative 1.265 to a positive 1.265, and it might help if I type in the integrals correctly. Now, instead of typing in those functions, remember I told you it's important to pay attention to which one's y1 and which one's y2. So what I'm going to do is I'm going to hit the variable button right here. Alright, it says vars, it's right next to clear. If I hit that and I scroll over once to y variables, I can pick a function. And so I know that I want the cosine function to be the first one, and that's my y1. So I'm going to pick y1. And then I'm going to subtract my lower function, which in this case was y2. So I'm going to do the same thing. I'm going to hit the variable button, go over to y variables, and pick y2 as my function. And then I'm going to go to dx, and I'm going to have it find the area. So the area is 4.995. Now this was just a shortcut for typing those in because sometimes these functions get really annoying. So if you can type it in once correctly, then you can actually use that shortcut. So we'll talk about it more in class if you guys need some help with how to get to that. And we're going to do question 3 together in class. So enjoy the rest of your spring break, and I will see you guys when we get back next week. Bye!